if you're gonna write the name, maybe you guys notice the pattern in the names. It's always the metals first, then the name of the non-metal, and we change the ends to IDE. If you have a transition metal, so anything in that D block like chromium or copper, we used charges. We used Roman numerals to tell the charge, like Roman numeral 1, Roman numeral 2. In polyatomic ions, you just say the name of the polyatomic ion. So if you see NO3, it's nitrate. If you see SO4, it's sulfate. So those are the rules for writing the names. Name the metal, name the non-metal, change it to IDE. Actually say polyatomic ions and use Roman numerals for transition metals. So here we go. Ca is my metal. I look in the periodic table and I see that Ca is calcium. Cl2 is my nonmetal. I look on the periodic table, it's chlorine. So I change chlorine to chloride. Maybe you're wondering why it said chloride on the previous slides, or oxide. Because the ID tells us it's negative, which means it's gained electrons from this guy. I don't have to say that there's 2, because when I tell you there's calcium, you know that that's a 2+, and you know chlorines are 1-, so you already know that you need 2 chlorines for every 1 calcium. Here, look at this guy, that's aluminum. Al is aluminum. PO4 is phosphate. Okay, and since I already know that, oops, this is a bad formula. I know aluminum is a 3+, so I know that I'm going to have 1 phosphate for 1 aluminum. So that's already good. AlPO4 is aluminum phosphate. Then next, we have, oops, you can tell I got tired while I was making these. Name this thing that I've given you the name for is the second question. Whoops. Oh well, we'll write the formula for this. We'll name this one. I have CuF2. So Cu is copper. It's a transition metal, so I have to say the Roman numeral. Let's see. I'll figure that out by looking at the fluorine. So I know I have fluorine, which becomes fluoride. I have to say the charge of the fluorine, so let's see, or charge of the copper. So fluorine is a 1-, and since there's 1 copper, that means this must be a 2+. I'm just kind of reverse switching. So 1 goes there, 2 goes there. The copper is a 2+. And the reason it works, if the copper is a 2+, it means that 1 copper lost 2 electrons, right? And it lost 1 electron to 1 fluorine, it lost the other electron to the other fluorine. If I have manganese 5 sulfide, manganese is Mn, it would be a 5+. Sulfide is S, it's 2-. Okay, so I'll just swap. So Mn2, oops, sorry, Mn2S5. That is a 5. Okay, so 2 times 5 is 10 for the manganese, 5 times 2 is a 10 for the sulfur. And one more slide. Okay, LiNO4, Li is lithium, so I name it lithium. NO3 is nitrate because I memorized that. And Cu is copper. I'm going to have to figure out the charge on this thing again. And PO4 is phosphate. Okay, so to figure out the charge on the copper, I look at what it's bonded with. Let's see, phosphate is a 3-, and there are 3 coppers. I have 1 phosphate, so this must be a 1+, right? 1 phosphate, 3 coppers, 1+, 3-. So the copper is a 1, so I just put copper 1. Okay, that's it. You probably need to watch things multiple times. There's plenty of practice in the packets. Make sure you do the whole packet, or all the packet that you can, if it's not an in-class thing. And you guys can shoot emails if you have questions. And finally, Johnny, your fish are doing great. Especially the one fish who's really, really greedy, because every time I feed the tank, I watch them, and that one fish eats all the food while the other ones just watch. And then I keep feeding, and finally the other fish eat too, and he gets like bored. That fish is like 10 times the size of the other fish.